theorem. If a finite group has at least one composition series. Now proof: if G is a simple, then G equals to G naught contains E series is a only composition series. So let us assume that G is not a simple, then there exists a proper normal subgroup H of G. If H is a maximal in G and E is a maximal in H, then G, H and series E is a composition series. Suppose H is not a maximal in G but E is a maximal in H, then there exists a normal subgroup K of G such that G contains K contains H. If K is a maximal in G and H is a maximal in K, then G, K, H and series E is a composition series. Now suppose that H is a maximal in G but E is not a maximal in H, then there exists a normal subgroup J of H such that H contains J contains E series. If E series is a maximal in J and J is a maximal in H, then G, H, J and series E is a composition series. Next, we suppose that H is not a maximal in G and E is not a maximal in H. Then there exists a normal subgroup L of G such that G contains L contains H. Also, there exists a normal subgroup N of H such that H contains N contains series E. Thus G contains L contains H contains N contains series E. If L is a maximal in G, H is a maximal in L and N is maximal in H and E is a maximal in N, then G, L, H, N and E is a composition series. Since G is a finite, there are only a finite number of composition, so G must have a composition series.